welcome back to our YouTube channel, and today we'll be solving the NCERT Intext questions and the exercise questions. So first, let's get on with the NCERT Intext questions on page 6, which is the second question. Let's get to balancing the equations, and the first question we have is hydrogen plus chlorine, which gives rise to hydrogen chloride. So we can write the equation as H2 plus Cl2, which gives rise to HCl. Now we can notice that we have 2 hydrogen and 2 chlorine on the reactant side and only 1 hydrogen and 1 chloride in the product side. So what we can do to balance this equation is simply add a 2 in the product side of the HCl. So now we can see that the hydrogen and the chlorine and HCl is balanced. So we can now say that the reaction is balanced. Now for the next question we have barium chloride plus aluminum sulfate gives rise to barium sulfate plus aluminum chloride. So now we can write the equation as BaCl2 plus Al2SO4 thrice, which gives rise to BaSO4 plus AlCl3. Okay, so now let's start. There's a quick reminder, if you have any doubt, do let me know, reach out to us, we'll clear it out for you. Now, let's start off by balancing the Als of the equation. So we have 2 Al on the reactant side and only 1 Al on the product side. So how are we going to balance it? By adding a 2 coefficient to the AlCl3 on the product side. So we get 2 AlCl3. Now we can see that the Al will be balanced. Let's get to the next thing which we can balance. So we have BaCl2 plus Al2SO4 thrice, which gives rise to BaSO4 plus 2 AlCl3. Now since we've balanced the Al, we'll also have to balance the Cl. Now Cl on the product side has become 6, but we have only 2 Cl on the reactant side. So how can we balance the chlorine? By adding a 3. Since we get 3 into 2, 6, so we'll have 6 chlorine. So we can simply add a 3 coefficient to the BaCl2. So we can now write the equation as 3 BaCl2 plus Al2SO4 thrice, which will give rise to BaSO4 and 2 AlCl3. Now you can see that both the equations have their Als and Cls balanced. Now we can see that we have Ba which is not balanced. So how are we going to balance it? Since we have a 3 coefficient on the reactant side, so now we can do the same thing on the product side. So what we can do is 3 BaCl2 plus Al2SO4 thrice, which gives rise to 3 BaSO4 plus 2 AlCl3. Now you will be able to see that the 3 Ba on the reactant side and the product side will be equal. So now we can see that all the elements are balanced. So hence we can say that the reaction is balanced. The next question is sodium plus water gives rise to sodium hydroxide plus hydrogen. So we can write the equation as Na plus H2O, which gives rise to NaOH plus H2. So how are we going to balance it? Let's see. We have 2 hydrogen on the reactant side and 3 hydrogen on the product side. So how can we balance it? Let's start off by adding a 2 H2O in the reactant side. So now we can see that we have 2 H2O that gives us 4 hydrogen on the reactant side and only 3 hydrogen on the product side. So now we have to balance the hydrogen on both sides. So let's start off by adding a 2 next to the NaOH, since then we'll have 2 hydrogen and 2 hydrogen, and that way the hydrogen will be balanced. So we can now balancing the Na on both sides, since we have 2 Na on the product side and only 1 Na on the reactant side. So we can simply add a 2 coefficient to the Na on the reactant side. So we will get 2 Na plus 2 H2O, which gives rise to 2 NaOH plus H2. Now we can see that all the elements are balanced. So thus the equation is balanced. Now let's get to the exercise questions, and here we are solving question number 5, which is about balancing equations. So the question is, translate the following and balance them. So let's see what's our first question. Hydrogen gas combines with nitrogen to form ammonia. So that's why the equation. So we get H2, which is a gas, plus N2, which is a gas again, gives rise to NH3, that's ammonia. So now let's start off by balancing N2. So we get H2 plus N2, which gives rise to 2NH3. Since we have to balance the 2 on the reactant side and we have only 1 on the product side, so we add a 2 coefficient to the NH3. So we get H2 plus N2, which gives rise to 2NH3. Now we have to balance the hydrogen. We have totally 6 hydrogen on the product side, that is 2 into 3, and we have only 2 hydrogen on the reactant side. So we can simply start balancing it by adding a 3 hydrogen on the reactant side. So we get 3 into 2, that is 6 hydrogen, and the equation goes as 3H2 plus N2, which gives rise to 2NH3. Now we can see that the reaction is balanced as all the elements are balanced. Let's move on to the next question. We have hydrogen sulfide gas burns in air to give water and sulfur dioxide. We can write the equation as H2S plus O2 gives rise to H2O plus SO2. Now let's start off by balancing oxygen. And a reminder, now suppose you're not sure as to what should the coefficient be, you can always start off step by step so that you will know if the equation is balanced or not. 1 O2 is already completed, so we can start off with a 2 O2, like go step by step. So we have H2S plus 2 O2, which will give rise to H2O plus SO2. Now once we do that, we'll have 4 oxygen on the reactant side and only 3 oxygen on the product side. So we need to balance oxygen again. So 2 is not the right number. So again, what we can do is we'll write a 3 next to the O2. So we'll have H2S plus 3 O2, which gives rise to H2O plus SO2. Now we have 6 oxygen on the reactant side and only 3 oxygen on the product side. So what we can do, again we need to balance oxygen. So let's balance it on the product side. So we have H2S plus 3 O2, which gives rise to H2O plus SO2. So let's add a 2 next to the H2O, which will give us 4 oxygen on the product side. Now we can see that the hydrogen is not balanced as we have 4 hydrogen on the product side and only 2 hydrogen on the reactant side. So we can add a coefficient of 2 to H2S so that we can balance the hydrogen. We now get the equation 2H2S plus 3O2, which gives rise to 2H2O plus SO2. Now we can see that the sulfur is not balanced as we have 2S on the reactant side and only 1S on the product side. So we can simply add a 2 coefficient to the SO2. So we get 2H2S plus 3O2, which gives rise to 2H2O plus 2SO2. Now what we can do is, now the equation is balanced. We just have to write the states of all the elements there. So we have H2S, which is a gas, oxygen a gas again, water a liquid, and SO2 a gas. Let's get to the next question. We have barium chloride reacts with aluminium sulfate to give aluminum chloride and a precipitate of barium sulfate. Let's get to the equation. So we have BaCl2 plus Al2SO4 thrice, which gives rise to AlCl3 and BaSO4. We can see that we have only 1 SO4 on the product side and we have 3 SO4 on the reactant side. So what we can do is simply add a 3 to the BaSO4. So we get BaCl2 plus Al2SO4 thrice, which gives rise to AlCl3 plus 3 BaSO4. Now you can notice that since we've tried to balance the SO4, we also have to balance Ba since we have 3 Ba also right now. Now we'll just add a 3 to the BaCl2. So we get 3 BaCl2 plus Al2SO4 thrice, which gives rise to AlCl3 plus 3 BaSO4. Now our Ba and our SO4 is balanced. So what's next to balance? We have Cl. So let's balance Cl now. On the reactant side, we have 3 into 2, 6 Cl, but on the product side, we have only 3 Cl. But you can also notice that we have 2 Al on the reactant side and only 1 Al on the product side. So we can simply add a 2 so that we can balance the Al and the Cl for AlCl3 on the product side. So we get the final equation as 3BaCl2 plus Al2SO4 thrice, which gives rise to 2AlCl3 plus 3BaSO4. Now let's get to our next question. We have potassium metal reacts with water to give potassium hydroxide and hydrogen gas. So let's see how to write the equation. We have K, that is a solid, plus H2O, that's a liquid, which gives rise to KOH, that is AQ, that is aqueous, plus H2, which is a gas. So now let's start off by balancing hydrogen. We have 3 hydrogen on the product side and only 2 hydrogen on the reactant side. So let's make the product side a little even, the hydrogen. So we can add a 2 to the KOH. So we get 4 hydrogen on the product side. So we get the equation as K plus H2O, which gives rise to 2KOH plus H2. Now let's try to balance the hydrogen on the reactant side. So we can get the equation as K plus 2H2O, which gives rise to 2KOH plus H2. Now the hydrogen is balanced on both sides. Now you can notice that we have an extra K on the product side. So how are we going to balance it? We can simply add a 2 to the K so that we can easily balance the reactant side of the K. So we get the final equation as 2K plus 2H2O, which gives rise to 2KOH plus H2. So now let's go to the next part. We have exercise questions, that is the question number 6. So let's see what's the question. Balance the following chemical equations, and the first question is HNO3 plus CaOH twice, which gives rise to CaNO3 twice plus H2O. Let's write the equation. So we have HNO3 plus CaOH twice, which gives rise to CaNO3 twice plus H2O. We can now notice that the nitrogen on the reactant side and the product side are not equal. So let's start off by balancing the nitrogen. So we can add a coefficient of 2 to the reactant side where we have HNO3. So we get the equation as 2HNO3 plus CaOH twice, which gives rise to CaNO3 twice plus H2O. Now we can see that our nitrogen is balanced, but our hydrogen is not balanced, as we have 2 hydrogen and another 2 hydrogen on the reactant side, that is 4 hydrogen, and we have only 2 hydrogen on the product side. So what we can do is add a coefficient of 2 to the hydrogen on the product side. So we'll get the equation as 2HNO3 plus CaOH twice, which gives rise to CaNO3 twice plus 2H2O. We can now say that our reaction is balanced. So let's get to the next question. We have sodium hydroxide plus hydrogen sulfate, which gives rise to sodium sulfate plus water. We can write the equation as NaOH plus H2SO4, which gives rise to Na2SO4 plus H2O. Let's start off by balancing the sodium on both sides, as we have 2 Na on the product side and only 1 Na on the reactant side. So we can simply add a coefficient of 2 on the reactant side of NaOH. So we get the equation as 2 NaOH plus H2SO4, which gives rise to Na2SO4 plus H2O. Now we have our NAs, which are both balanced, and we have to balance our hydrogen. On the reactant side we have 4 hydrogen, but on the product side we have only 2 hydrogen. So now this is a very simple thing to balance, or 2 to the product side of the H2O. So now we can see all our elements are balanced, and the equation will become 2 NaOH plus H2SO4, which gives rise to Na2SO4 plus H2O. We can see that all the elements are balanced, and hence we can see our equation is balanced. Now let's move on to our next question. So we have sodium chloride plus silver nitrate, which gives rise to silver chloride plus sodium nitrate. We can write the equation as NaCl plus AgNO3, which gives rise to AgCl plus NaNO3. Now when we see the equation, we can see that all the elements are balanced, as Na, Cl, Cl, Ag, AgNO3, NO3. So all are balanced. So hence we can say that this equation is already balanced. Now let's move on to our next question. We have barium chloride plus hydrogen sulfate, which gives rise to barium sulfate plus hydrogen chloride. We can write the equation as BaCl2 plus H2SO4, which gives rise to BaSO4 plus HCl. Now, we can see that almost everything is balanced except the chlorine, as we have 2 Cl on the reactant side and only 1 Cl on the product side. So all we can do is add a 2 to the HCl on the product side. So we get the equation as BaCl2 plus H2SO4, which gives rise to BaSO4 plus 2HCl. And since we've put the 2 to the HCl, even our hydrogen is balanced. So now we can say that our equation is balanced. Next, we have exercise questions, that's question number 7. So question number 7 says, write the balanced chemical equations for the following reactions. And our first question is, calcium hydroxide plus carbon dioxide gives rise to calcium carbonate plus water. Now let's see how we can write this equation. CaOH twice plus CO2, which gives rise to CaCO3 plus H2O. From the given equation, we can see that all the elements are balanced on the reactant side and the product side, and hence we can say that our equation is already balanced. So now let's get to our next question. We have zinc plus silver nitrate, which gives rise to zinc nitrate plus silver. We can write the equation as Zn plus AgNO3, which gives rise to ZnNO3 twice plus Ag. Now we can see that we have only one NO3 on the reactant side and two NO3 on the product side. So let's go to balance the NO3. So what we can do is to simply add a 2 coefficient to the AgNO3 on the reactant side. So we get the equation as Zn plus 2 AgNO3, which gives rise to ZnNO3 twice plus Ag. Now what else do we have? We have to balance the Ag since we've added 2 as a coefficient to the AgNO3 on the product side. So what we can do is we add a 2 coefficient to the Ag. So now our final equation is going to be Zn plus 2 AgNO3, which gives rise to ZnNO3 twice plus 2Ag. We can now notice that all the elements are balanced, and hence we can say that our equation is balanced. Now let's get to our next question. We have aluminum plus copper chloride, which gives rise to aluminum chloride plus copper. We can write the equation as Al plus CuCl2, which gives rise to AlCl3 plus Cu. So let's see how we can balance it. We'll start off by balancing the Cl2, as we have 2 Cl on the reactant side and 3 Cl on the product side. So what we can do is we can make it as a multiple of 3 and 2. So what we can do is we'll add a 3 to the CuCl2 on the reactant side. So we get the equation as Al plus 3 CuCl2, which gives rise to AlCl3 plus Cu. So now what we can do is now we'll add a 2 to the AlCl3, so that it becomes 3 into 2, 6 on both sides and becomes equal. So we get the equation as Al plus 3 CuCl2, which gives rise to 2 AlCl3 plus Cu. Now we have our Cl's balanced, but you can see we have 3 Cu. So how we'll balance it is add a 3 to the Cu on the product side. So now we'll have our Cu's also balanced. So we get the equation as Al plus 3 CuCl2, which gives rise to 2 AlCl3 plus 3 Cu. Now we have to balance our Al. So how are we going to do it? We get the equation as 2 Al plus 3 CuCl2, which gives rise to 2 AlCl3 plus 3 Cu. Now we can say all our elements are balanced, as we have 2 Als on both sides, 3 Cus on both sides and 6 Cl on both sides. So now we can say that our equation is balanced. Our last and final question is barium chloride plus potassium sulfate gives rise to barium sulfate plus potassium chloride. So let's see how we can write the equation. We can write it as BaCl2 plus 2SO4, which gives rise to BaSO4 plus KCl. Equation is pretty much balanced, but we just have 2K on the reactant side and 1K on the product side. So all we have to do is balance the K's. So you can see we can add a 2 to the KCl on the product side. So we even balance the Cl also. So we get the final equation as BaCl2 plus K2SO4, which gives rise to BaSO4 plus 2KCl. We can now say that our equation is balanced. Well, that's a wrap for today's video, guys. I hope you enjoyed it. If you did, drop a like, hit the subscribe button, turn your post notifications on, and thanks for watching.